Welcome back to our Python Quickstart tutorial series. Today's topic is object-oriented programming in Python. These topics include the definition of classes, the concept of inheritance, and operator overloading. Okay, before we start on object-oriented programming, let's make sure we go to the kernel, restart, and clear all outputs so we have the best interactive experience. Next, make sure the trusted button shows. If it's not trusted, please accept and trust that source so your notebooks work properly. So let's start with objects. Objects are somewhat different from data, but not entirely. What is it? Data, normally we think of just as numbers, text, etc. Object-oriented programming combines data with a set of methods that are designed to interact, to operate on that data. So instead of having data organized on one end and having functions that need to work with various types of data, we define the combined set. There are good ways to think of those things, and I like to bring up some examples here. So, for example, you have a project that requires a series of companies, agencies, subcontractors to work together. So these entities that work on a project need to exchange certain information. Where is the property? What are the rules? How do I design this? Where do I order something? How shall I build something? But on the other end, they may have their own proprietary information. There's a company that holds a patent and doesn't want to share all the details. There is the public agency that has to do some privacy protection and cannot give you access to the data directly. There is the bank that may hold some information, but you don't need to see everything. You only have your certain teller to work with. That are all examples in the way how we try to break down tasks into entities that hold information, that have a certain ability, and then we add to this a communication channel. That may be our contact person at the other company, that may be the teller at the bank, whatever, who have a certain well-defined set of channels to collaborate, a clear defined set of data that you can exchange, but on the other end, they also protect the individual data sources, the individual companies. And that's pretty much how we think of designing classes. In Python, everything is an object. An integer, a list, etc. These are actually objects. Think of a list as data plus the extra ability to pick the ith entry by simply giving it an index, or the way to modify one element of the list, to append to a list. These are all methods that go with a list. They don't work with any other data type. If a different data type needs a similar method, they need to implement that method. So let's look a little bit deeper into the idea of classes. And I want to use this by looking at code. I want to make that simple. And I say, I want to define a class that describes a pet. So I start thinking, what do all my pets actually have? Hey, I may have a cat, you may have a dog, somebody may have a goldfish, but typically, if they're a pet, we give them a name. So I design my pet class as an object that knows it's a pet, that can remember its name, that can tell me its name, or in a way, I may be able to look up its name. If you think of a pet, maybe it doesn't tell me, maybe it's just a little tag. Either way, there's a way to retrieve that name, and maybe there's a way to create a sound as a method. So the way how I do this is, first, I start with a definition. And the definition, remember, is like the definition of a function. We're not executing any code. We try to describe how that object looks like. So if we think of a function does operations but doesn't necessarily hold data. If we need a combination of holding data, in our case the name, and to perform operations, that's when we start creating a class. I create a class named pet. It is a common convention to use class names to start with an uppercase character. And here, object, treat this for now as a keyword. In our next session, we will look a bit deeper into variations of that argument, but typically it's a keyword. That's the definitions. That means from here on, Python, we have everything in the same indentation. A class I can use here with 3 quotes, a multi-line string as a comment. So this could be just a simple description that I put in there that later when I look at my file, I know what that was about. Then comes the definition of methods. Every function that is attached to that data, that's a method of that class, needs to be defined inside the class. That means we define functions. We see the typical thing, function, a function name, arguments, definition, and then comes the function body. So far, so good. We can have multiple of those functions, but now comes the interesting part. There are some predefined functions that we need to define. And the one that we typically have to define is called underliner, underliner, init, underliner, underliner. The underliners are reserved for internal functions. So we typically do not call them. And other than the predefined functions that exist within Python, we should never use function names that start and end with double underliners. It's simply a safety so we don't mess with the original system. We call the init function a constructor. It is called when we create a variable of that type. Then the other thing that is important is the keyword self. Every method starts with the first argument, self. We will see later that we don't have to enter that one. That is a very peculiar concept in the beginning. It is referring to the current instance of a class, and that's basically like an individual variable. I will illustrate that in the example shortly. And after the keyword self or the keyword argument self, we can use any type of variable. Here, I just want to say, if I have a pet, I want to be able to give it a name. And there is another nice thing that works with any type of function. We can set default arguments. Default arguments means I have a variable name, and in the header, I assign to it a value. In this case, the string unknown. If the user calls this with an argument, then name is assigned by the user argument. If the user omits that argument, then the default argument will be used instead. The nice thing is that way we can ensure that we will always have a variable given. Let's look at that line of code that I have. Name is a variable or a parameter that's handed to the function. Any variable within a function or from the header lives as long as the function is running. The moment the function is completed, we lose it, we forget about it. A class is an object that shall be able to hold data. If it shall remember something, then we can use that keyword self as self dot, and then any variable name that we want. Any variable that starts with self dot will be remembered by that class object, even if that function is completed. So name, the variable name, will disappear upon the completion of the init function, but the variable self.name will be remembered and can be used by any other method. I'm using here a few other techniques or a few other methods. Standard method, strings, underliner, underliner, str, underliner, underliner, is a method that is needed to convert the value of that instance into a string. And that's used by the print command. So when you say print something, it is actually saying take that something, convert it to a string using underliner, underliner, string, underliner, underliner. That should return, that's why I need a return value, a string. In our case, self.name is a string, so all I have to do is return self.name. Self.name is, again, it's a member variable. It is available throughout any method inside the class. There is another method very similar, that's represent. We don't need to implement it, but it should be implemented such that it returns a string that could, when executed, create a copy of that object. That is used by the debugger, and it's used by some printing and backup tools. So in this case, I wouldn't worry too much about it. I give it for completeness. Again, every method has as first argument the keyword self. It has otherwise no public argument. And last but not least, I want to use a user-defined method. I said a pet may be able to create a sound. So I'm creating a method sound. It needs one argument, that's self, that's the minimum. And this method, I just, instead of creating sounds, I print whatever my name is. And since I don't know what kind of pet that is, I just assume by default it's silent. So if we do this, we define a new data type in that sense, that's pet. Hey, data types, integer, list, string, float, pet. How do we create one? The way is very simple. I create a pet, and the pet's name shall be Buddy, and I assign that to variable A. Let's have a second pet, and I call that one Kitty, and I store that in variable B. Let's try that. Nothing special happened. I had my two instances created. But what's actually happening? Let's check that out. Pet is executing the constructor pet class, init function, name. What happened with self? Self is the variable to which we assign it to. So in that first line, this actually turns into self is A, and self.name, when executed, turns into A.name. When I execute the second line, we use the pet class. That is the constructor. It calls this, but it's assigning it to B. So self becomes B, and the second execution will create a variable B.name. So if we look at this, and I want to do this just by looking at the variables itself, I could do A.name. I get Buddy. And if I do B.name, It's Kitty. So the class created these variables as instant variables. A and B are instances of pets. They can keep a variable that we had a self.something, they get their own private copy of it. There's a different way we can use print A, print B. How did that work? The print statement needs to convert the object pet A to a string. So it's calling the pet.string underline string function with A, and that returns a string a.name. When I call that for B, it's actually calling b.name. So that way we are hiding our storage scheme from the user and make that pretty easy. At that point, we can just use pets as normal data types. And I have that here a little bit more written out. I have here my two examples. The represent idea is, as mentioned earlier, it should return a string that would recreate the object A. And that is how we created the object A. But the nice thing is, we've seen that in other data types that we could say variable taught a method means apply the sound method to A, sound here without an argument, a.sound. But the way how it works, A is a pet. So it looks, hello pet, do you have a sound method? And that keyword self is then replaced by A. So the sound method gets the argument A and it's executing pet.sound A. And here we have the placeholder in the template string, print a.name is silent. Let's test that this really works. Body is silent. Pretty easy way to work, define a class. So as a quick recap, again, what's going on in a class? In a class, we need to define a constructor. In the constructor, we should actually initialize all self.variables. Whatever we want to use, we could theoretically create the self.variables in any of the methods. But the only method that we know the sequence of in which it will be called is the constructor, because when we create a new instance, we call the constructor. The other methods like string, represent, sound may be called never, may be called in any arbitrary sequence. So you can never assume that string would be called before sound or sound before represent. The only thing you can be certain in this concept is that the constructor is called when this thing is created. And that's why all the variables should be that member variables that start with self dot should be initialized there. The self dot member variables, that's the data, that's the memory. The functions that we are defining here, these are the methods that are attached to that class. That's chapter 1 of object-oriented programming. And we're going to learn more what that's going to be useful for in our next video.